Okay, so in continuation with the previous session, now we go and represent the type of follower and their motion which has been seen in this diagram. So as we seen, depends upon the type of follower movement, depends upon the motion which has been exerted by the follower. Based upon these two different categories, we used to say the motion of the follower has been traced. Okay, so in this way we are going to study about simple harmonic motion of the follower. So before that, let me know what is meant by simple harmonic motion. Simple harmonic motion means there is a to and fro motion which maintains the constant kind of oscillation without either without making any kind of unbalanced force or unbalanced effect. You can never able to notice this kind of unbalanced stage in their follower motion. So here the simple harmonic motion is also coming under those category. So accordingly we need to calculate the motion of the diagram with respect to the given follower movement. So let me start with the small procedure how the simple harmonic motion will plays a role, or how can we draw the diagram which we use to represent the follower motion in simple harmonic. Okay, so for any follower motion diagram we need to start with this baseline. So along with this baseline, here take one point as a midpoint and take this as a radius, draw one semicircle. So when we construct the semicircle, okay, so once if we made a semicircle, we need to divide the semicircle in 6 different stages. The first one, it is a 0, second one, it is the first line, third one, it is the second, fourth, fifth, sixth and seventh. So according to the type of angle, since the semicircle having 180 degree, we need to divide the 180 divided by 6, which means for each line it having 40 degree. So the same kind of space, this crank angle which has been divided, how much amount of division which you have done in the semicircle, the same amount of divisions that we need to make in the crank angle also. So this crank angle generally we need to assume assume 1 centimeter, which is equal to this much amount of degree. So that degree has been divided in terms of 6 angular divisions. So that is what you have seen in this diagram. So on left hand side it is a simple harmonic motion, on right hand side we need to calculate the crank angle and divide the crank angle divisions into 6 equal parts. And we need to find out where are the intersections which has been done over these 3 different kind of category. The first line which meets at the first line of division, we can name it as the 1 dash, and the second line of crank angle and the second line of follower motion which has been intersected, we need to give the name it as then 2 dash, and similarly the third intersection which has been made along with this crank angle and both the lines has been intersected at common point, that is what we call that, that is it, name it as a 3 dash, and fourth line which we made intersect with this fourth division of the cam, and we need to give the name it as a 4 dash, and similarly we need to repeat the procedure for all other points which has been made by the cam rotational motion. So that is what here the representation has been shown, 1 dash to 2 dash, which make a connection of those points. We need to draw the tracing of the diagram in order to represent the cam following motion. So that is what we have analyzed by using the simple harmonic motion in different kind of crank angles which has been represented both in positive cycle and as well as the negative cycle. So the second category which is coming under the topic of constant acceleration and deceleration. So constant acceleration means there is a motion which has been repeated due to the continuous effect of forces, and deceleration means there is a force which has been getting retained or due to some kind of damper which has been exist in the cam motion. That is what we call that deceleration. So these two different kind of motion has been predicted with the help of the graphical diagram. So that is what we're going to see in our upcoming representation. Thank you.